Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to learn how to predict cryptocurrency prices in Python using deep learning. So let us get right into it. Now, before we get into actual coding, I want to mention that this video is sponsored by Tab9. And before you skip that part, because it's just a basic sponsorship, let me once again tell you that I would not recommend something or advertise something unless I think it's useful and interesting. And I've been using Tab9 for the past couple of weeks myself, and I really enjoy it because it's an auto-completion model, or you could say an auto-completion engine, which is powered by deep learning and the GPT-2 language model, which means that it gets better over time. It gives you very good and long auto-completion suggestions, and it fits your programming style, or it adapts to your programming style over time. So you can go to their website and you're going to see that they support almost all modern programming languages, or actually all modern programming languages and almost all programming languages that are relevant. And you can see they support JavaScript, Python, TypeScript, PHP, Java, C++, Go, Rust, and many more. And you can also see that Tab9 is integratable into most IDEs, or at least in all IDEs that I know and think are relevant. For example, VS Code, IntelliJ, PyCharm, Golang. You can see the Atom editor, Sublime Text. You can see Android Studio. You can see Emacs, and even though you cannot see it here, it's also supported in Vim, because I have a lot of Vim users in my followers, or among my followers. And you can see that it is easily integratable with all these languages and all these IDEs, and it's also totally free. As you can see on the pricing page, you can see that the basic code completions here are totally free, so you don't need to pay a single cent, and you can use Tab9 and the intelligent auto completions. And also, because that is also a concern for a lot of people, especially if you're using the cloud model, the privacy, Tab9 takes the privacy very seriously. So you can go to tab9.com, you can click on code privacy, and you can see that they don't use your data for anything else but better auto completions. And even if you don't want that, you can just turn off the cloud model and you can use the local AI model instead of sharing your data with the cloud, even though they're not doing anything stupid with your data. Some people just don't want it. So in case you're one of those people, you can just turn it off and use the local model. So Tab9 is a very interesting product. I highly recommend you to download it, and you can find a link in the description down below. Click it and take a look and tell me in the comment section what you think about Tab9. All right, so I need to add one more disclaimer here because this is a financial topic. This is not investment advice. This video is not financial advice in any way. It is programming advice. I'm showing you how to use Python and neural networks to work with sequential data. So I'm showing you how you can get data of the past few weeks, months, and years, and then predict the next day. Or try to predict the next day. This is not a guaranteed model for making profits with cryptocurrencies. In fact, you may lose money using this model. So the focus in this video is on the programming and not on the financial trading. You can try to use it. I don't recommend it because that's just a machine learning model that is going to predict one day based on 60 days or based on 90 days. And the predictions are not going to be super accurate. Now, you may make money with it, but you may also lose a lot of money with it. So this video is not investing advice. I'm not responsible for any gains or losses that you take using that model. I'm just showing you how to implement such a thing in Python. All right, so having said all that, we can start by installing some libraries. We're going to open up a command line or the favorite terminal of your choice, and we're going to say pip or pip3 install NumPy first. So we're going to need NumPy, we're going to need pandas, we're going to need matplotlib, so the basic data science stack in Python, and we're also going to need pandas data reader, so pandas-data reader, like that. This is important because this library is going to get the financial data from the Yahoo Finance API for us. And one thing that I also think that we're going to use is MPL Finance, even though I'm not sure if we're going to use that. I actually don't think that I'm using it in this project, so let me just see. No, I don't think that we need MPL Finance, but if we need it, you just say pip install MPL Finance, like that, MPL Finance. But I don't think that we need it for this video. And we're also going to need some machine learning libraries. So we're going to say pip install TensorFlow. And we're going to say pip install sklearn, or also scikit-learn. This is actually the same library. So those are the libraries that we're going to need, and we can now go ahead into the code, and once you have installed them, you should be able to import them. So we say import NumPy as MP. As you can see, a good auto completion here from Tab9. import matplotlib.pyplot as plt, then import pandas as pd, and import pandas data reader as web. So those are the basic libraries that we're going to need here. We're also going to use datetime to just use datetime as dt. And then we're going to say from sklearn dot preprocessing, we're going to use a scaler. So the import min-max scaler. This is what we're going to use to scale the financial data in between 0 and 1. So when you're working with neural networks, it's best to have a data that is either scaled from 0 to 1 or from -1 to 1, so the neural network can work with it better. Once we have that, we're also going to say from TensorFlow.keras.layers, we're going to import the dense layer, the dropout layer, and the LSTM layer, which stands for long short-term memory. This is a recurrent layer, which is very important for sequential data. And we're also going to say from TensorFlow.keras.models, we're going to import the sequential model. So do we have a space here? Yeah, there you go. So this is what we're going to need: dense, dropout, LSTM, sequential, and a scalar. So those are the libraries. We now imported them. And the next thing you want to do is you want to get the financial data. And this is actually quite easy. We need to know what cryptocurrency we're actually interested in. So we say cryptocurrency. And for example, let's say we're interested in Ethereum. Then we say ETH. If you're interested in Bitcoin, you say BTC. If you're interested in Ripple, you say XRP. You can just Google the ticker symbols. We're going to use BTC here, for example. And what's important is we need to also have an actual currency, or actual currency is maybe not the right term, a basic currency that is not a cryptocurrency like a dollar or euros to compare the Bitcoin to, because we want to know at the end of the day how many dollars is one Bitcoin worth, or how many dollars is one Ethereum worth. So we're going to call this against currency, and this is going to be US dollars in this video here. So after that, we're going to specify a time frame for the training. So we want to know, okay, what are we going to use as a training data here? We're going to say the start is going to be dt.datetime 2016, 1st of January, for example, and the end date is going to be now. So dt datetime now, it's going to be today. So this is the time frame that we're going to look at for the training data. And in order to get the actual data, we're going to say data equals web.data reader, and we're going to pass an f string here, which is going to be the cryptocurrency. So we're going to say f cryptocurrency against the dollars, so against the against currency, like that. Because that is how you get the price of the cryptocurrency in US dollars, or in this against currency, from the Yahoo Finance API. And the next thing is we need to specify that we want to use the Yahoo Finance API, and we need to specify the time frame, so start and end. So the next step is to go ahead and prepare the data for the neural network. We're going to say prepare data in a comment here. And the first thing we want to do is we want to scale down the data so that it is squeezed in between 0 and 1, so that the neural network can work better with it. But before we do that, I want to show you that the data frame, or what the data frame looks like, by just calling data head, so that you can see the first couple of entries here. And you're going to notice that this is a full data frame with different columns. You have open, high, low, close, volume, adjusted, close. And what we're actually interested in is just the closing value of a particular day, because that is what we're going to use as a basis, and that is also what we're going to predict. So I'm going to delete that here, and we're going to create a scalar first. We're going to say scalar equals min-max scalar with a feature range of 0, 1. This is just the boundaries. We're going to squeeze all the values in between 0 and 1. And in order to get the scaled data set, we're going to say scaled data is scalar.fitTransform. And we're going to fit transform data, but not all of it, but just a close column here, the values of it. And then we need to reshape this, reshape -1, 1, because that is the format that the scalar needs. So then what we're going to do is we're going to choose a number for the prediction days. The prediction days are going to be the number of days that we're going to base our prediction on. So the idea of this whole script is that we look at the past X days, for example, 60 or 90, and then we predict one day in the future. So we look at 60 days and then we predict the 61st day, for example. And for this, we need to decide how many days we want to base our prediction on. Of course, if you just base it on the last 10 days, it's going to be more actual data or more recent data. But if you base it on 60 days, it's going to be a little bit more conservative. So we're going to say prediction days is going to be 60 in this case. And then we need to prepare the training data. We need to have an X data and we need to have a Y data. So the Y data is going to be the label, or the result, you could say. We're doing supervised learning here. We have 60 days and we have an actual value. So we want to train 60 days. We want to show the neural network 60 days and it has to predict the 61st day. So we're going to say X train, and Y train is going to be empty list and empty list. And then what we're going to do is we're going to fill those lists up with actual values. So we're going to say for X in range prediction days. So we're going to start at 60, going up until the length of the whole data set of the scaled data. And what we're going to do is we're going to say X train dot append. And here we're going to append chunks of or packages of 60 days. So we're going to say scaled data, and we're going to start at X minus prediction days, which is why we start at prediction days, because this is then 0 in the first iteration and goes on and on afterwards. So 1, 2, 3, and so on. And we're going to go up until X. So we're going to take the span of 60 days starting at X minus prediction days up until X, and 0 as the dimension here. And this is what we're going to add to the X train, and to the Y train we're going to add something else. We're going to say Y train dot append. To Y train we're just going to append the last day, so just X, the day after that. So we're going to use the time period from X minus prediction days up until X to predict the X, the actual X, because I think that when we do this, X is not included, and this is the day after that period. So this is how we fill up the list. And one last thing that we need to do is we need to say X train and Y train is going to be np.array of X train and np.array of Y train. So this is just turning it into a NumPy array. And after that, what we're going to do is we're going to say X train. We need to reshape X train. np.reshape X train, and we're going to just add one more dimension. We're going to keep the shape, but we're going to add an additional dimension. So we're going to say X train dot shape, not dot scale data, dot shape 0, X train dot shape 1 and 1. So this is how we do that. All right, now I saw that the camera was quite bright because the weather outside is changing. I fixed that. I hope this was not too annoying. So the next thing we're going to do is we're going to build a neural network. So we're going to create the neural network, which is going to be the model that we're going to use for the prediction. And for this, one thing that you might want to try is you might want to downgrade your NumPy version if you have some issues. If you don't have any issues once the code is written, you don't have to do anything, but I had some issues because I had NumPy 1.20 installed, and maybe when you're watching this video in the future, it's no longer a problem, but for me, I had a problem. So what I had to do is I had to downgrade NumPy to the version 1.19.5. How do you do that? You just say pip install numpy equals 1.19.5. This is only something that you want to do if you have some problems with NumPy. If you don't have any problems and the script works fine, you don't need to do anything. But this is one fix if you have the same problem that I had. So we're going to say model equals sequential. We're going to just do a basic sequential model here. And we're going to add LSTM layers and dropout layers. LSTM layers, so long short-term memory layers, are going to be the recurrent layers that we're going to use to memorize stuff. Since we're dealing with sequential data, which has, day 1, day 2, day 3, and so on, it's sequential. Those layers are very powerful because they are specialized on that sort of data. And long short-term memory layers are just memorizing the important information and feeding data back into the neural network. So I'm not going to explain the details here because we're actually more focused on the coding here. Maybe I'm going to make a theoretical episode on that as well, but this is the basic idea of an LSTM layer, and the dropout layer is just for preventing overfitting. So in order to not overfit the network, we're going to add a dropout layer or many dropout layers in between. So we're going to say model at the first long short-term memory layer, and it's going to have 50 units, and it's going to return sequences. So return sequences equals true. And then we're going to say the input shape of that is going to be the shape of xtrain. So xtrain dot shape 1 and 1, like that. Then we're going to say model at dropout 0.2 just to prevent overfitting. And then we're going to say model at LSTM again with 50 units. Of course, you can try to tweak those values. Maybe you're going to get better results or worse results. We're going to return sequences here as well. Then we're again going to say model at dropout 0.2. And then we're going to add an LSTM layer here without return sequences true. And then we're going to add one more dropout layer. And finally, what we want to have, this is important because in the end, we don't want to have a bunch of different values. We want to have one value. We just want to have one number that is going to indicate the price. And for this, we need to add a final layer, which is going to be model.dense. And it's going to have just one unit. So units equals 1, because that is going to be the price prediction in and of itself. So then we need to go ahead and compile the model. We're going to say model.compile, and we're going to use an Adam optimizer. Optimizer equals Adam. Loss equals mean squared error, as you can see here. And then we're going to train the model. So we're going to say model.fit xtrain ytrain. We're going to use 25 epochs, and we're going to use a batch size of 32. So this is how you build and train the model. Okay, so next up we're going to test the model. So we're going to add a comment here, which is testing the model. And for this, we need to specify a time frame for the testing data. We need to load some testing data. And then we're going to compare the test results, the prediction results on the test data with the actual results. And for this, we're going to say test start is going to be DT datetime. And here we need to say something like 2020, for example, 1st of January. This is going to be the start date for the test data. And the test end is going to be DT datetime dot now, which is today. So then we get the test data, and we're going to do this the same way we did it up here. So we're going to copy that here, and I'm just going to rename this to test data. And of course, we need to change the time frame. So in the end here, we're going to say test start and test end, even though end and test end are actually the same. So this is how we get the test data, and then we want to have the actual prices. So we're going to say actual prices is going to be test data close dot values. We're going to get the closing values here as the actual prices. And then we're going to combine this data set, so the test data set, with the data set from before. So we're going to say total data set is pd.concatenate. So pd.concat, and we're going to pick data close with a capital C and test data close, like that. And the axis that we're going to use is 0, even though I think that's the default, but I'm not sure. So this is the total data set, and what we're now going to do is we're going to get the model inputs. We're going to create the model inputs that we're then going to use for the prediction. So we're going to say model inputs equals total data set, and we're going to take the length of the total data set here minus the length of the test data set. So we're going to go back before the test data set, and we're also going to go back for the prediction days so that we can start choosing from the 60 days before that, and we're going to go up until the end. We're going to take those values. So basically, in a better way explained, this is just total length of the data set, all the values, minus the test data, minus 60 days for the predictions. We're going to get those values as the input, since we want to predict the values after that. So we're going to get that. We're going to say model inputs equals model inputs dot reshape. We need to reshape them again with -1, 1. And of course, we need to scale them down again because our model is trained on values between 0 and 1, and those values are not between 0 and 1. So we need to say model inputs equals scalar dot fit transform model inputs, like that. This is how we create the model inputs for the testing. And now we need to make some predictions using the trained model. So we're going to say xtest is an empty list. And for x in range, we're actually doing the same as above when we created the training data. We're going to start again at prediction days, going up until the length of the model inputs. And we're going to say xtest.append model inputs from x minus prediction days, so minus 60, starting at 0 essentially because we started prediction days, up until x and 0 here. This is how we create the test data. Then of course we say this is a NumPy array, so we say xtest equals np.array of xtest, and we need to reshape it again, adding a third dimension. So xtest equals np.reshape of xtest, and the shape is xtest shape 0, xtest shape 1, and 1, like that. So then we need to get the predictions. We now have the actual prices and we want to know the prediction prices. So here we're going to say prediction prices is going to be just the model predicting, not mode, model.predict on the test data. And of course, we're going to then have the actual prices. So we don't want to have the scaled values. We want to inverse scale them. So we need to say the actual prediction prices are not what we get from the model, but the actual prediction prices are scalar.inverse transform the prediction prices. So then we get the actual values. Now, last but not least, we need to now visualize that we have the prediction prices and we have the actual true prices. So what we're now going to do is we're going to plot both of them in Matplotlib by saying plt.plot. We're going to plot the actual prices in black color. So color equals black. And the label is going to be actual prices. Then we're going to plot the prediction prices in, let's say, green color. And we're going to say predicted prices. And of course, we can add some stuff like titles. So plt title. And we can say cryptocurrency price prediction, like that. And plt.xlabel is going to be the time. We're not going to add actual dates here, so we're just going to call this time. And we're going to call the y-axis the price. And of course, we're going to also have a legend since we have the labels, and the location of the legend is going to be upper left. And then we say plt.show in order to visualize all that. Now, I think that the training is going to take a while. I'm going to start the model to see if we have any mistakes here. And if it starts training, I'm just going to skip that part and come back to you once it's done. But maybe we're going to get some exceptions. So let's see if it starts training. What do we have here? Just some warnings. Sequential has no attribute dense. Oh yeah, because we set model.dense. This is of course a problem. We need to say model.add dense layer. But except for that, since we came up until this point, this should be fine. So it should start training any moment once it's loaded and done with the warnings. But other than that, it should work. Yeah, you can see it starts training. So I'm going to skip that part here and I'm going to come back to you once the training is actually done. All right, so the training is done and the curve looks quite good. But before you get too excited about this, because this is almost the same curve, you need to keep in mind that we're only predicting one day based on 60 days. So it's not like we looked at the first 60 days and then the model predicted this curve. We looked at 60 days and the model predicted this single point. We looked at 60 days after that and it predicted that point. And because of that, the curve is kind of accurate. But it's not like we just start at 60 days and we predict all that and it's almost the same, because that would be like magic. It's not like that. What you would have to do to build a model like that is you would have to feed its own prediction into it as the past 60 days. So you would have to look at 60 days, predict the 61st day, and then in order to predict the 62nd day, you would have to look at 59 actual days and the one day that you predicted and so on. And after 60 iterations, the model would base its prediction on, or its predictions on, the predictions that it made in the past. So there's no actual data involved anymore, which means that slight errors in the predictions in the beginning will cause huge errors afterwards in the future predictions. So you would not get a curve like this. Actually, you can see that the curve is kind of lagging because you can see Bitcoin fell here and the model predicted it will fall here after it already fell. So this is not really good for predictions. Sometimes, however, you can see something that happens before that. So I think here you can see the model is rising before it actually rose. So it can predict sometimes, but most of the times it's just going to lag behind. Now, how can we use this to actually predict days in the future? So not just looking at past performance, but looking at the actual prediction for tomorrow. In order to do this, we're going to add a comment here, predict next day. And what we're going to do here is we're going to say the real data that we have up until now is model inputs, length of model inputs, plus 1. This is why what we need to predict the next day. Minus prediction days, up until the length of model inputs plus 1, 0. So this is the data that we're going to use that we have up until now. Of course, we need to again say real data equals np.array real data. And we need to again do the same thing with the dimensions. So I'm going to, let me just copy this line here and replace xtest with real data and replace it here. Actually, we can say xtest replaced with real data. There you go. So this is how we can do that. And then we're going to do the prediction. So we're going to say prediction equals model.predict on the real data. And prediction is just going to be scalar inverse transform prediction, and we can then print the prediction in US dollars. Now, I'm not going to run the model again because it trains quite long on my laptop, since my laptop is not really good. But this is how you can do it. You just predict and then you can print the prediction. Now, one last thing that we can do here, which is kind of experimental, is we can target a day in the future that is not just the next day. So we're not targeting the 61st day, but we're targeting, for example, the 90th day, which means that we're looking at 60 days and we're still just predicting one single value. We're not going to predict a sequence of movements. We're going to predict one price in the future, but it's not going to be the 61st day, but it's going to be the 90th day, for example. And we can do that by just saying, for example, future day is going to be 30, which means that we're going to predict not the next day, but the 30th day after those 60 days. And what we need to do in order to do that is to just subtract it here in the loop. So we're going to say up until length scale data minus future days or future day. And down here, we're not going to predict X, but we're going to predict X plus future day. This is just a slight change that we can use here in order to predict not the next day, but 30 days after that. So once the model is trained, you can see that this is a result with the future day prediction, so with 30 days into the future, and it looks actually better. Now, I'm not 100% sure if I read this right, so I don't want to claim that this is in any way predicting the Bitcoin price, but if I read this right, this would mean that the model at this point in time thinks, for example, that in 30 days, this is going to be the price. And then you can go 30 days to the right and you can see if this price is right or not. And if this is the case, this is actually quite a good prediction because it says that in 30 days, the price will be here, and in around 30 days, the price is actually here. So this is not a bad prediction. However, this is not always going to be that good. And actually, in this case, it probably just thinks that it's going to go straight up because it started going up here. So it did not predict, for example, that it's going to fall down in between. It just saw that it's rising, and it's probably going to think that it's going to continue rising. But you can play around with the values. You can try to enter 100 in a future day variable. You can change the Bitcoin to Ethereum or to Ripple and so on. And you can play around and see if the predictions make sense or not. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Also, don't forget to check out tab 9 in the link in the description down below. And of course, hit the subscribe button and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.